The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, thank you for joining us today for today's webinar for ag retailers to discuss the benefits of custom strip tillage for nutrient placement. My name is Jane Petzold and I'm the project coordinator for water resources management here at the IPM Institute. We're joined today by my colleagues Mark Adelsberger, resource management specialist, and Dr. Thomas Green, president and co-founder of the IPM Institute. I'm also pleased to welcome our guest speakers. Today, first we will hear from Dr. Scott Shearer, a professor and chair of the Food, Agricultural, and Biological Engineering Department at Ohio State University. And then we will hear from Craig Hiemstra, the vice president of marketing and sales for Environmental Tillage Systems Incorporated. Before we begin today, I just want to go over a couple of housekeeping rules. Audience members will all remain muted during most of the presentations, but please make use of the question pane if you have any questions throughout the presentations. We'll have time at the end of each presentation for questions, and I will read your questions to our presenters for them to respond. I also want to note that we were approved for 1 CEU in nutrient management. We will be submitting our list of attendees after the conclusion of this webinar for approval, so you should see your CEUs appear on your account if you are attending here today. So at this point, I'd like to turn it over to Dr. Thomas Green, who's going to just give us a couple of minutes introduction to the IPM Institute and what our projects are all about.
Thanks, Jane. Go on to the next slide. So we're an independent nonprofit based in Madison, Wisconsin. We have about 16 staff, including Mark Adelsberger, who works in the Sandusky River watershed on our project. Our focus is really on market-based mechanisms to improve health, environment, and economics in both agriculture and in communities through IPM, or Integrated Pest Management, and other best practices. Some of our projects include work with food companies like Cisco, Whole Foods, McDonald's, and their potato supply chain on broader sustainability initiatives that include IPM. We also work in the non-ag arena with pest control companies, using our Green Shield certified program, where we go on site with those companies and evaluate what they're doing, and if they meet our standards, they can market themselves under the Green Shield certified logo. We also work with school systems as well, and go on site with schools and other facilities to evaluate their pest management programs and help them get better control of pests and minimize pesticide risks and exposure. And the project today, if we turn to the next slide, Jane, that we're focusing on is an effort in the Western Lake Erie Basin to work with ag retailers to identify and promote and track those products and services that ag retailers offer that can contribute to keeping phosphorus on cropland and out of our surface water. We work also to address disproportionality. So Pete Nowak at Wisconsin spent a lot of his career researching and educating about the fact that it's a minority of our acres that are really contributing the most to our issues, and we need effective strategies to identify those acres which may be at risk because of soil types and slopes and proximity to surface water, but also to practices that may be present on those farms, and find solutions for those particular acres. And I think that really applies to today's topic as well, in that certainly with the technology and time and resources that we have these days, we're not going to incorporate nutrients on all of our cropland. So we need to be strategic and identify those acres that would really benefit from additional practices to protect those nutrients. We also work to increase participation in NRCS programs for nutrient management and IPM as well. We held a training in Ohio this past year with NRCS and Ohio State University and trained 43 participants, 31 who went on to become technical service providers in NRCS programs and eligible to work with farmers under NRCS contracts to plan and implement improvements. And then finally, early on in our project, we heard from ag retailers and others that non-operators are a really key audience for improving practices and that they have a lot of influence on what happens on their ground. Many of them are certainly not experts in agriculture, not aware of the issues that we're facing in the watershed, and so working with the Sandusky River Watershed Coalition, we identified those non-operator landowners in the Sandusky and have been regularly communicating and engaging with them and have had some good results in terms of responses from those landowners and participation in finding solutions and working with their tenant farmers to make improvements. Next slide. I think that may be it for me, Jane. Thank you.
Thanks, Tom. And at this point, I will turn it over to Dr. Scott Shearer, who's going to give us some background on the environmental benefits of strip tillage from a research perspective.
Thank you very much, Jane. I don't know whether this was intentional or not, but you'll notice my title slide is black and white, and what I'm going to talk about is anything but a black and white situation in some respects. And I want to chat a little bit about what's going on in the western basin of Lake Erie, and some of our, at least, assessment of what may be at the root cause of the problem. And we're going to talk a little bit about a couple technologies, if you will, or a couple thoughts on the use of technology as to how we might address it. The recognition is that it's difficult for us at this point in time to identify the specific regions within the watershed that are contributing the most to some of the dissolved reactive phosphorus concentrations going into the lake. We can do that by subwatersheds, but within those subwatersheds, obviously the management practices and the cropping systems vary quite a bit. And so I'm not suggesting that we have a silver bullet. What I am suggesting and providing some thoughts on in terms of how we might use technologies such as strip till to address the dissolved reactive phosphorus problem in the western basin of Lake Erie. Next slide. Most people have probably heard about what's going on in Lake Erie, and you see these photographs from time to time. If you go back into the 1960s and 70s, there was substantial phosphorus loading of Lake Erie, and it compromised a lot of the activities on the lake, most specifically the sports fishing in some respects. There was a lot done at that time to kind of stem the movement of soil into the lake, and a lot of conservation measures and programs were put in place, and they substantially reduced the amount of phosphorus loading on the lake at that time. Again, they were looking at total phosphorus loading, and I think more recently, while the total phosphorus loading on the lake still remains below what might have been occurring back in the 70s, the real concern today is the dissolved reactive portion of the phosphorus, and really it's a very low rate of phosphorus movement into the lake in some respects, but the effects are pretty catastrophic when you look at the ratios of nitrogen and phosphorus flowing into the lake. At this point, I want to make a couple statements. I've been kind of close to this problem by virtue of the fact I'm at Ohio State University. I've been privy to a lot of conversations, but my background is primarily as a cropping systems person, and so there are going to be some soil fertility issues that other people will be much more qualified to talk about. I think I understand moisture movement within the soil pretty well, but this is not a single discipline problem in some respects. It's going to take the efforts of many disciplines to address and resolve the situation going on in the western basin of Lake Erie. Next slide. One of the other things I want to mention in this, and this was alluded to at the beginning up front in some of the kind of background information, but I think the recognition is that a lot of people are focused on sustainability today, and I only put this slide in there because Walmart has a very interesting policy that will go into effect on nutrient sustainability, as I understand, by 2020. And so increasingly it's going to be incumbent upon a lot of producers to be able to demonstrate that they're using practices that result in sustainable cropping systems. And so while there may be a lot of concern over what happened in Lake Erie recently, please understand that this is also very important to a lot of retailers today in terms of how they're viewed by the general populace in some respects. Next slide. Pea management concerns, and I want to talk about this, and this is not a blanket statement. Again, every location is slightly different, and systems vary quite a bit, but really what's happened with conservation tillage, and conservation tillage and no-till have been very good things in terms of environmental sense, but I think what's happened over the last 20 to 25 years is most of the P or phosphorus is still surface applied. And there's two or three things occurring. A lot of people talk about nutrient stratification. I'll address that. But the other thing is the timing of the application coinciding with some rather catastrophic rainfall events, at least in recent years, have contributed substantially in terms of the dissolved reactive phosphorus going off into the lake. The other thing that people are beginning to recognize, and we have some data on a slide coming up here, is that with that nutrient placement on top of the soil, which is traditional in broadcast applications, that we may be seeing stratification. And specifically, as we begin looking at the upper layer of soil, the 2 inches, if you will, we see some elevated phosphorus rates in that location. We always know that phosphorus is seeking kind of a balance between what's available and what's tied up and bound to the soil in some respects. But when we see an elevated level of phosphorus in that upper level of soil, obviously more dissolved reactive phosphorus might be available at that point in time. Next slide. This is some data from Laura Johnson of Heidelberg University, and I want to let everybody know that obviously I borrowed this, but I think she's done a very good job of illustrating the nature of stratification. And what she has been doing is sampling at some different depths. We can talk about the implications of this in some respects, but in general, I think people that have adopted conservation tillage, no-till practices, that there is a tendency with continuing phosphorus application, and from recent statistics, we know that about 95% of the corn acreage in the state of Ohio gets an application of phosphate fertilizer during that cropping season, and to a lesser extent soybeans, obviously, but phosphorus is still one of the primary nutrients used in the state of Ohio. We go into the western Lake Erie Basin too, and we have quite a bit of intensive crop production. There are other parts of the state where animal nutrient sources are important as well, and I don't want to minimize some of the environmental situations associated with the application of animal manures, but in general we begin to see the stratification. The left-hand chart, you see that the mean levels in the 0 to 1 inch at the 0 to 1 inch depth obviously are quite a bit greater than they are perhaps at the 5 to 8 inch depth, and it just shows that stratification issue that's occurring in the soils. If we go back prior to the 1970s, perhaps a lot of moldboard plowing, we inverted the soil, and obviously we mixed the soil pretty well, and so we didn't see that kind of stratification or buildup in the top layer. Again, this is not a universal. This is happening in some locations, but I think the recognition that it is occurring is one of those contributing factors. Next slide. This is some data from Kevin King, and I want to note here that Kevin has been looking at edge of field effects. Kevin is with ARS here in the Soil Drainage Unit on the Columbus campus, but obviously a USDA group. Kevin has been looking at off-site movement of dissolved reactive phosphorus over the surface as well as through tile drains. And in this case, obviously, the no-till is resulting in higher runoff in comparison to some sort of rotational tillage and or tilling every year. Now, this might be surprising to some people, but I think the thing that's going on is there's mixing of the phosphorus with the soil and incorporation a little bit below the soil surface, and that's one of the kind of take-home messages here. The other thing is we're seeing a fair amount come out through the tile drains, and it's Kevin's contention in some respects, and I don't pretend to speak for Kevin necessarily, but what Kevin's thought is that there's quite a bit of macro pore flow going on, and that dissolved reactive phosphorus ends up in the tile pretty quickly. But one of the unfortunate aspects of tile drainage is that's going off into our ditches without going through vegetative buffer strips for those areas where those conservation practices are being used. And so kind of a bit of a different thing in terms of the surface runoff. Next slide. The source of P has a lot to do too with the nature of the dissolved reactive movement off-site, and please notice the inorganic versus organic forms of fertilizers, animal versus commercial fertilizers in some respects, and the availability. And so, for regions of Ohio where the animal densities are a little bit higher, obviously there's a bit of a different dynamic in those locations. Next slide. Strip till considerations. When we look at moving towards strip till, there are two benefits that I think that can be realized by using strip till to place phosphorus. Number one, that there is some tillage occurring, and the nice part about the tillage, and I don't want to get into a discussion necessarily about the fact we should be tilling soil, but the nice thing about some tillage is you're breaking up macro pore flow, and that is one of the conduits obviously causing the dissolved reactive phosphorus to move to the tile. The second thing is with strip till, we can incorporate phosphorus below the soil surface, and so that helps us avoid the stratification situation that might be occurring. There are some thoughts too about maybe creating a phosphorus-rich zone below the soil surface and then controlling the placement of seed relative to that, and maybe the benefits that will accrue to that situation. Several strip till considerations, and I don't mean to speak for all regions of the country, but the style of the shank is going to be important, and I think it's going to be unique to the soil conditions and perhaps depth of compaction. Attachments to thoroughly mixed P in the tilled zone, obviously injecting behind the shank and then getting some mixing occurring below the soil surface. Configurations which minimize surface disturbances. The important thing is we want to make certain that we leave the residue intact, and again, we want to try to stem or stop the off-site movement of soil particles from going into the waterways. The source of P then obviously becomes important in terms of characteristics that may affect metering and placement within the tillage zone. Next slide. I'm going to review a couple ways of approaching things, and I know that the speaker coming up next is going to spend a little bit more time on this, but there's a variety of strip till equipment available today, and what I'm going to show is one approach that a producer might use, and that is essentially assembling their own system. There are some advantages to that in terms of cost and in terms of integration with other equipment that may exist on the farm. But one of the ones, because we're an Ohio-centric institution, we have an interaction with Unverferth. And again, I'm not endorsing a product, but they make their Ripper Stripper. Next slide. One of the things that Unverferth does not do is provide for metering of phosphate fertilizers, and so a producer using a Ripper Stripper from Unverferth may want to go out and purchase something like the Gandy Orbitaire for metering the fertilizer and obviously placing it behind the shanks of the Ripper Stripper. Next slide. Variable rate obviously becomes important in this situation too. One of the things I try to remind producers of in some respects, just being able to shut off fertilizer in areas of the field that have high phosphorus soil test levels is a significant advantage over perhaps broadcast or field average application. But again, variable rate application using this to drive the Gandy Orbiter for metering granular fertilizers may be one way that producers have. Next slide. And then obviously buying completely turnkey integrated systems coming from companies such as John Deere and many others provide another option for producers as well. And the final slide, I believe. Strip till limitations. I think the main thing you want to be concerned about is proper placement of phosphorus using strip till implements. Universal solutions may not be possible with varying soil conditions and terrain. What I'm suggesting is what may work in one part of the country or one part of Ohio may not work in another. And so I think you really have to get with the vendors and see what the opportunities are and see what their experience has been in terms of matching up some of the strip till equipment with locations. Proper mixing of P in the soil strip may require correct shanks and attachments for the soil type. And we want to recognize that soils vary quite a bit. This last one, I think, is the most important one, and it was kind of alluded to up front, is ground speed is going to be a critical issue. In other words, field capacity. How many acres can we do per day and per hour? And what I'm reminded of is in the fall, especially when you're doing tillage, that window may be pretty narrow depending upon the weather conditions. And so this is something that might affect the ability to cover enough acres and really cause a lot of producers to move in this direction towards strip till. So I think that's what I have in terms of the way of formal presentation. Be happy to answer questions at the appropriate time.
Great. Thank you so much, Scott. And we do have time. We have a couple of minutes for questions here. We have a couple of questions coming in. Let's see. Here's a question. What depth of incorporation should be used for strip tillage or broadcast?
Well, I think one of the main things is you want to see some sort of mixing with the soil. And so part of that's going to depend upon the nature of the shank and the attachments on the bottom of the shank. We have to be careful, though, that we just don't drop fertilizer into the slot necessarily, depending upon the rates. There is a chance that you might have the granular material kind of aggregating together and staying in one place in some respects. Obviously, when you get into a seeding zone, you're also going to be concerned about what's happening, the interaction between the seed and the fertilizer. And so placement is critical, and also placement of the perhaps the seed relative to that zone till area may be critical as well. And again, everything's going to be based on the rates at which you're adding fertilizer to the zone till area. But again, anything that you can spread that out horizontally and mix it with the soil is a very good thing to do.
Thanks. And some more questions coming in here. Is using a planter mix down when putting seed considered strip tillage?
I'm sorry, that question again?
Is using a planter mix down when seeding considered strip tillage? There are some people that will probably vacillate on whether it is or not, but I think the bottom line is any time you're doing any kind of tillage ahead of placing the seed, whether it's done in a separate operation or the same operation. I know there are a number of culture carts and things like that may be advantageous, but working that soil zone ahead of the planting operation, in my estimation, that is a form of strip tillage again. But there might be some purists that see those being at two different operations at different times of the year as well. And do you have any information concerning phosphorus rate reduction in uptake efficiencies in banding versus broadcast?
I know that has been one of the factors that's been discussed quite a bit in terms of the advantages of using strip till. I think it boils down to plant uptake efficiency in some respects. I've seen studies that have been very positive about being able to reduce phosphorus application rates and still maintain plant growth and nutrient uptake. I'd hate to make blanket statements on that because that's really an area that's kind of getting out of my my zone of expertise in some respects, and I'll defer to some of my soil scientist colleagues as well as agronomist colleagues for a more definitive answer on that. But I have seen quite a bit in the way of publications that advocate that line, yes.
Great. And then one more question. Is there a benefit to placing the phosphorus when planting versus a pre-plant broadcast application?
Very much so. And I think, you know, a lot of producers moved away from starter fertilizers essentially because it slowed down the planting operation. I appreciate that because planting time is precious, and especially in wet years. But we may see a trend back towards at least meeting a portion of the plant's phosphorus needs with starter fertilizers. I know in some locations, depending upon soil test levels, some producers have been able to supply all of the phosphorus necessary for plant growth. And again, that's a little bit dependent upon what the soil test values are. But there may be a trend back towards that, depending upon how things play out in the state of Ohio, specifically in the northwest portion of the state.
Great. Well, thanks so much, Scott. At this time, we need to move on to our next presenter, Craig Hiemstra. We have some additional questions that we'll try to get to at the end of the webinar here. Thank you so much, everyone, for your great questions. And so now I will let Craig take it away.
I'm assuming okay, there. Well, thank you, Jane, and also to the IPM Institute. I very much appreciate this opportunity to share with the audience some of the case studies that environmental tillage systems has been experiencing with retailers across the Midwest. And again, as Dr. Shearer has alluded to, do want to talk more about perhaps placement of nutrients throughout our brief conversation this morning. Next slide. Just a little bit about environmental tillage systems, or ETS. The Ohio market may not know us as well as some of the central states such as Minnesota, the 3 I states, but we are a smaller, real niche company doing strip zone tillage in the Midwest that is based out of Faribault, Minnesota. We happen to have customers in 16 different states and 3 different provinces of Canada, and even New Zealand and Australia. Next slide. And again, this is just a quick snapshot of where our customers are at in the Midwest. We've had a lot of growth, and I want to share that today as well. In the no-till markets of the Dakotas, I think it does have some application to what we're talking about, even though I know we're in Ohio. But and we can move to the next slide. But as you can see, we're continuing to advance to the east. One thing, as a service provider and manufacturer of strip zone tillage equipment, and if you do the evolution of our company, and Scott had alluded to this, we find that there's been a lot of equipment built that usually entails 3 or 4 different manufacturers. One thing that customers have commented is that ETS does provide like a hitch pin ready, very heavy duty commercial grade precision zone till system. So that is one of the benefits of that we found as we've evolved, even working more with the retail market, who are sometimes looking for a commercial grade custom application type of equipment, going over a lot of different conditions and acres. Next slide, please. One thing that's unique, a unique offering of ETS is that we do offer a shank. I'm going to talk about that, but that actually evolved for us later in the game, primarily because the retailer market, was looking for the ability to still continue to apply NH3, ammonia gas, and look at doing strip till in one pass. So I am going to talk to that here, just a few slides. down the presentation. But actually, the company's unique offering and patent in strip tillage, when we're talking about true vertical strip tillage, was this invention, which we call the Soil Warrior X row unit. That's how we started. We didn't have, a complete system 10 years ago. And I'll show you a little animation coming up here, but again, what's unique is we have this row unit that's actually a 30-inch, we call it, cogwheel, that has these tillage bits that fracture the soil, break the compaction, lift it, and then, again, you're able to even come back with the same row unit with vertical coulters and prepare, the seedbed for planting. So again, in the heavier type soils of the Midwest, this is replacing like rippers, field cultivators, 2-3 passes of tillage or even more. And again, and I think everybody, I'm just assuming, knows that with our strips, they are more 25%, 30, a third of the soil is being disrupted, but everything else remains the same. So this just gives you a look at that. But Jane, if you go to the next slide and run the animation, I think that'll help everybody visualize what the Soil Warrior row unit does, and that's unique. So what you're watching, and there's 18 inches of vertical travel, so it actually walks over rocks. This is great with our Michigan customers as well as Minnesota, and pushes things down. But this will allow you to get your P and Ks down a good 7-8 inches in depth, primarily in the fall. What you're seeing at the end is that same row unit converts, you can go to the next slide, Jane, to a double coulter that sometimes is just used for one pass tillage in more arid soils. And again, depending on the soil health, sometimes the soil health gets so good that the cog is almost too aggressive, and the shallow tillage, giving you about 6 inches of depth, is more than adequate. So I don't want to go into a lot of detail here, but just to kind of summarize in a nutshell, and you did hear this from Dr. Shearer, with the strip tillage system, whether it be a Soil Warrior or others, there's a real advantage of the placement of the fertilizer. And again, I'll speak to this because a market that I didn't even think we'd touch would be the no-till. We saw, let me back up. Our mission was more thinking that conventional tillage would move toward more strip tillage. But again, if we just think through this, and we are talking about, the compaction that Mother Nature brings, to farmers, coupled with, broadcasting P's and K's and fertilizers out on top, it does allow us to get the nutrients placed closer to where, the plant can actually uptake them and use them perhaps even sooner than they would, just traditionally with like your P and Ks. Again, we kind of talked through how this cogwheel fractures the soil and the compaction and leaves a very nice seed bed, and we'll see some pictures. So go ahead and advance the slide, Jane. I don't think I need to talk to this too much. In fact, the nice thing about Ohio is, there's been a lot of movement towards no-till, but again, in other states, there are still, as we call it, the recreational tillage out there. People like to work up the soil rather than leaving the majority of it undisturbed. And again, this is, what happens after a major rainfall event is, the movement of the soil. Next slide. This is a picture of a trial that USDA had conducted up in the Minnesota area. I think you've perhaps experienced or seen different demonstrations, just soil infiltration, with water and water holding capacity within the soil. But on the right side, in this picture, that is still traditional moldboard plow. Yeah, good old Minnesota, still a lot of plowing. And then in the middle, kind of the picture with a little water in it would be the chisel rip. And then the one to the left is actually the Soil Warrior strip tillage. This is about a 7-year trial. Again, oddly, not a lot of yield difference between the conventional and the strip till, but I did want to mention that, but this specific year in this picture, that the rainfall, this was an early rainfall event, and then all summer it didn't rain. There was actually like a 30-bushel yield difference, for example, between the strip till and then the moldboard plow conventional acres. So there is a lot to say about being able to keep the water for the plant, again, from a productivity standpoint. Next slide, please. Again, this is really what we're seeing, just a testimonial from one of our customers, but we very much see this as a trend that we have a lot of partnership operations out there, father-son. This is what we really enjoy, is seeing the next generation kind of looking for something different, and again, looking at preserving the soil into the future. But Ben Pedersen here, he's done a lot of just trials with, and there's some nice articles that have been written where they just compare the conventional versus strip. And even if you said there isn't a yield advantage, just the savings, the cost savings are well worth, the investment time, and of course, the longer-term benefits of saving the soil. I do have a slide at that to address the economics of that at the end. Next slide. This is just a picture of, what we like to say is, why wouldn't you want to plant into something like this? To me, it's almost the perfect seed bed come spring. This is fall, and this is what we're really looking for in a more traditional one-pass NP and K in the fall. Get ready to let the farmer plant it in the spring. Next slide. Another real common practice, and we see this more like in Ohio and the eastern Corn Belt, it's catching on more in the central west, is just incorporating a cover crop. There are some opportunities to even put a cover crop on with a Soil Warrior. We've got some very innovative farmers, but again, just wanted to give you a different look. This is not using a shank type delivery system, but again, you're able just to put some pretty beautiful zones in, again, to plant into a cover crop scenario. Next slide, please. And again, everybody is speaking to this, but this is being very common lore here as far as the 4R nutrient stewardship program. We're all looking at the right product at the right rate at the right time and right place. So if you haven't heard this, I'm sure you're going to hear more about this. Again, very much on track and aligns with the information that I believe Dr. Shearer was speaking to regarding placement of P or the phosphorus. One thing I always find interesting is all of our equipment allows you to do variable rate deliveries, yet a lot of customers or farmers don't use that option. They continue to use kind of a blend, but they're not necessarily putting fertilizer on it yet as a prescription. I'd say 20%, about 20% of our customer base is doing real prescription feeding, in my opinion. So again, a lot of opportunities as we move forward here. The other thing I should say is we are working on university trials. We're in our second year. Some trials happen to be at Purdue University with Dr. Vine, and again, we are trying to measure just the stratification of the fertilizer being placed. Again, what kind of soil mixing are we getting? What's the movement? And there hasn't been a lot of work when we just get into comparative tillage practices. but we did find it interesting, and we'll continue to vet this out, that there was a 9-bushel yield advantage of strip till versus no-till. Again, what do I attribute that to, or what could be attributed to? Again, our belief is it's lending more towards the placement, of the nutrients, and giving that uptake, and perhaps helping with some of the compaction issues. So again, I mean, I want to make sure I embrace no-till. I'm not opposed to that, but again, we can just start seeing the different trade-offs. Next slide, please. Just wanted to show you a picture, and not that we have retailers that are participating today. Some may still be using ammonia anhydrous in their custom application programs. It seems like it could be a trend that is starting to go away, depending on where you are. There's more regulations in different watersheds on the use of anhydrous, but bottom line, it is just very economically driven, by producers. Next slide, please. So, for this need, we did develop a row unit that allows us to either put a shank on, for deeper, like P and K placement, as well as the anhydrous, or, the machine can run primarily in the spring with or without shanks. We have people, starting to put on just, urea or different blends at pretty high rates. And what you'll find amazing, or we find amazing, and you'll see it as you talk to some of our retail customers, we still have designed this equipment to, and not so much with the anhydrous when you have a shank, but without the shank, we have a lot of folks running this piece of equipment at 8 to 10 miles an hour. And if you're in the commercial application business, speed is part of what needs to happen, and we'll talk a little more about that. Next slide, please. Again, we have a pretty in-depth case study, but I just pulled a slide, kind of a highlight of different co-ops and operations that happen to be using our Soil Warrior in their operations. And again, this is developing, but it was brought up earlier. Acres covered in a day, with a 12, 16 row type piece of equipment, with filling and everything. I'd say 250 acres to 300 is pretty common. And we have some folks, because they're running off of RTK and everything going all night, you'll see 500 acres a day. But again, that's just all usually a fight against Mother Nature. But we are starting to accumulate this data. It does give you some of the range of what people are charging for these services. Again, it is different, but in summary here, we see a range of $25 an acre that's being charged in a custom application setting. That would be for the tractor, the operator, and the strip till equipment unit. Next slide, please. This is a retailer primarily located in the Dakotas, kind of more off the Missouri River and into Texas, but that way I don't have any competitive information on if I've got Ohio retailers, but I did think it was worth sharing as one of the 4 case studies that we have. But they're a very large retailer operating more in the western and central Corn Belt. Next slide, please. I've got just a picture of one of their about 20 locations in South Dakota. You can see pretty big equipment, quad tracks, the large John Deere. These are 60-foot. They happen to be 3 Ben Soil Warriors. We actually have 3 delivery compartments. That allows these retailers to even apply micronutrients with variable rate delivery. But again, they've really set these up to hopefully run more like 10 miles an hour, get over a lot of acres, and they are really set up to do custom application in large fields. So I know terrain's a little different than perhaps Ohio and other central state locations. Next slide, please. Again, their results, I mean, last fall they did almost close to 10,000 acres with 2 machines. They have 3 this year. And again, the customers seem to keep signing up. And again, I've been kind of shocked that they've been more no-till type farmers than just even conventional till. And on average, they were finding about a 13 bushel advantage in the no-till scenario. Next slide, please. Again, a testimonial from the person who was a regional specialist for Wilbur Ellis. Again, he was early innovator and adopter, and as you read through this, and we don't have a lot of time, but again, they are seeing the benefits to their customers, and really providing kind of this turnkey solution and allowing these farmers just to come in and plant after the program has been prescribed to their fields. Next slide, please. I want to bring a testimonial here just closer to home. This is a group, crop fertility specialists. You may have heard about them, or CFS, as they're known to go by, and affiliated with COVA. This is one of the managers using a soil warrior in Burnettsville, Indiana. But again, they really enjoyed and have adopted the use of strip till, because it allows them to put the nutrients down, and as they note here, especially the urea ahead of the planter, and then it spoon feeds the crop throughout the season. And they've been seeing good yield results. So again, as part of the proper placement and the correct amount, we are seeing more split applications as well, with nitrogens programs, and again, just gives a lot of options. Next slide, please. And we're getting close to the end here. But this, again, is a farmer from Kenton, Ohio, Brian Watkins. He spoke at the first National Strip Till Conference this summer. We could follow up with a more detailed presentation. This is just pulled from one of his slides that he had given, but he had done an MBA class, and he did comparisons of no-till, strip till, and conventional till. And again, I thought this really was compelling. Again, just to jump to the meat of it, if you look at the middle of the slide, the corn yield to cover the entire cost of $350 of strip till versus no till is you need about 3 bushels more, and with the conventional, you need 10 bushels more. So I look at that to say, hey, are you really going to get that many more bushels to cover all these extra costs of higher horsepower equipment, more trips, labor, so on and so forth. So again, I did not give this piece justice, because it's a fantastic presentation that Brian had developed. But if you're into the economics and you want to see facts and analyze cost, to me this is one of the top pieces of information that's out there. So next slide, and we'll just start to summarize here. So again, we went through a lot pretty fast, and you can access our website. We'll have that information here towards the end. But in my opinion, because again, our audience being a retailer, custom application, the opportunity is, providing a one-pass economical solution, for farmers out there. They've been used to perhaps, just the broadcast fertilizer, running the big floater. Sometimes farmers then come with their NH3 bar, and then, doing tillage in some cases, and doing all the trips. But, there is a commercial grade equipment here that, in my opinion, is very much scalable. That can be used as a value-added service, to those real innovative, farmers, looking for higher yields and really working towards the better best practices available to them. Next slide. And I just wanted to show, I saw a lot of pictures of machines with dry tanks and even some anhydrous, but we could configure, we customize machines so you can use liquid on the same cart as you use dry. We have that going on. Next slide. And for some of the manure folks, we actually build machines that, in this picture, it's 40 foot wide. We're up to rates of 3,000 gallons a minute with a drag hose, again, serving the needs of, large dairy producers, pork producers that really are getting more benefit from their nutrients, their solids, than, days of just getting it out on the field and letting it run off. To me, this is very much a game changer. And the last slide, just to summarize here. Again, a good picture from the Michigan area, Ohio. This I can remember. There's a lot of rocks in this field as well, but very happy customer that, again, I think is doing it right. Where you can run the machine in between the rows. Next year you'll be back on that old row. So, and he's incorporating cover crops, and again, just top-notch practices in my mind, to optimize the nutrients, the placement, and a lot of this is just having the technology that enables them, to be able to do this. So, websites there. I talked about ETS, but our website is soilwarrior.com. We're excited because we just relaunched our new look today, so please feel free to check that out. Also, I want to mention we sponsor a resource center just specific to strip tillage on the Ag Professional website. So on Ag Professional, which some of you may be members of, you can access that site and go to the Strip Till Resource Center. And there's just, it isn't just about ETS, but just a lot of good information about strip till in general. So again, thank you very much for allowing us to participate today, Jane.
Thanks so much, Scott, Craig, sorry. That was great. And at this point, we have time for questions, and we have some questions coming in already. We have a question about fertilizer rates when using strip tillage. Can they be reduced, and how would this affect the field? What are the recommendations, and how do they change?
Do you want to direct that to anybody specific, Jane?
Maybe Scott, would you be familiar? Yeah. Would this be within your expertise?
Well, it's a little bit out of my field, but again, what I'll reiterate is I've seen several studies suggesting that rates can be reduced. The question I think that comes to mind in some respects is whether you're continuing to mine the phosphorus in the soil surrounding, or the plant stands, obviously, and or whether or not there's better uptake because of the zone or strip tillage approach to placement. And so I encourage people to proceed carefully and definitely get the advice of your crop consultants and university agronomists in that area. I think there's some possibilities there, but again, a little bit out of my field of expertise, and I would urge people to move forward kind of cautiously. So.
And Jane, just quickly, Craig here, I would more than concur. I think one thing, though, people should note, because this comes up a lot, you're not necessarily cutting your rate, but if you do elect to do a strip or band, correct, in this type of tillage methodology or practice, there's just more efficiency. You're not broadcasting it versus stripping, if that makes sense. So there is some savings. Our customers would say on average they save 20, perhaps up to 30% their input costs. But I would very much talk to a certified agronomist and specialist in their area.
Great, thank you. And I have another question. Do lower rainfall amounts in the West make strip till more economical compared to eastern states like Ohio, where there's typically more rainfall?
It might be directed at me here, Jane. This is Craig. Yeah, the Western, just in general, is one pass. It's more arid. They may get half the rainfall, of Ohio. So very much, I do not see any more than one pass. However, as we go east, I know this sounds odd, and especially when we're in no-till, but if you are trying to get your pea in very deep, like in the fall, but we've also seen a trend, not only with that, so there is, let's say, this pass in the fall, but there is the ability then to just freshen that zone in the spring, and farmers are perhaps even trying to get some of the fertilizer and all the equipment that they've kind of hung on the planter, perhaps off, and just, do a second pass over the same zone, freshen it, and then they just come with the planter and plant. So, this is a tricky one because, I like to say, well, we want to minimize passes, but we don't know what the conditions will be or what, what program, what is the farmer trying to accomplish. So it does depend.
Great, and this question is probably directed at both of you. Are either of you aware of any contour strip tillage applications going on?
This is Scott. I'm not personally aware of those, but it seems to make perfect sense to me. Obviously, I think you would have to be careful in any kind of tillage situation when operating on ground with a little bit more relief. And what I keep thinking is you have to be careful you're not creating a conduit to concentrate water as it runs off the land. And certainly strip till normal to the slopes would be a very good way to minimize the chance of runoff or concentrating flow that would create gullies and as it washed off the side of changing elevations within fields. And so I'd caution people, and I think that's a very good suggestion that strip cropping on the contour would be a very favorable thing to do.
Yeah, I would agree with Scott. Just if you can still see the picture, I assume you can. I didn't mention it, but we happen to offer steerable carts, but you'll see a globe, let's say, right on top of the machine itself. So we do have farmers that will use these systems in their contour type farming. There is a point that you probably shouldn't, that you shouldn't be doing it, period. But again, the technology is very much advanced. We've really improved, so we don't have the extreme skip rows and the bleeding of the planter trying to match up with the strip till rake. That's your biggest challenge. But I can say over the last 2 seasons, we've seen a lot of advancement with the software technology providers in this area. And again, by steering the cart steering the strip till cart as well as like the planter, if you can get those matched up, you can have good very good results.
Great. And one more quick question. What is the most common timing for strip tillage applications? Is it in the fall or in the spring, or fall followed by a spring pass?
Well, this is Craig, and Scott may have an opinion. It's all the above. You're going to need to kind of read the market, and if you are the precision ag professional, what kind of programs are you looking at to enhance productivity and profit for the farmer?
Yeah.
But yeah, the only thing I can reference here, just quickly, we did see a presentation by Dr. Vin at this National Strip Till Conference. He did show data that is trending, that we're seeing more strip tillage in the fall. One pass in front of the planter. If I might add that. Go ahead, Scott.
The comment that I'll make very briefly is I think it depends upon the depth of tillage and the soil conditions. I would be for certain if it's dry conditions and you're shattering soil or moving a lot of soil, the fall obviously is the time to do that, to allow that to mellow over the winter. The question that always comes up whenever we talk to anybody is a slot where you may be seeding in the springtime that the seed drops down and you have difficulty controlling depth. And so again, it's going to have a little bit to do with soil moisture levels when the strip tillage operation is going on in some respects. And again, sometimes you get kind of hamstrung in the fall. You can't get all the strip tillage done that you want. But it seems to be, at least most of the people that I talk with, that seems to be the preferred method is to get it done in the fall and then be able to come back in the spring where things have kind of mellowed out and some of those slots have sealed up a little bit.
Great. Thank you so much, and thank you everyone for attending today. A recording of this webinar will be made available on our website, www.partnershipfarm.org. And I will say that this has also been approved for one CEU in nutrient management, and so we will be submitting those lists of attendees for approval following this webinar. So thank you everyone for attending. Thank you so much to our presenters, Scott and Craig. I really appreciate it. And yep, that'll be all for today. Thank you. Bye-bye.
Okay, John, it's okay if we get off, Gene.